Okay, now then suppose the question is like this. They given some signal x of t, then find the even and odd part of the signal. Find even and odd part of signal, odd part of given signal x of t. Okay, again the x of t nature could be anything. Suppose if they given the signal like this. Okay, now the given x of t itself, it is like this. Okay, now what do you expect? Okay, once if you try to extract even part from this, okay, what you'll get? Anybody? So now, because if you see, they are giving this signal as a general signal x of t, but this signal is actually a even signal. Okay, so even signal consists of only even parts. So once if you try to extract even part of the signal from this signal, then you will get this signal only. Okay, once if you take even signal, you will get, if you try to extract even part, you will get even signal only. So just we will apply the formula. What is the formula? X even part of the signal is equal to x of t, okay, plus x of minus t divided by 2, okay, divided by 2. Okay, now already we are having x of t. What about x of minus t? Okay, so the x of minus t would be like this. Again, here in this case, the x of minus t also will be like this only. Okay, minus 1 to 1. Again, this is t 1 and x of minus t. Okay, now what will happen if you try to add both the signal? You'll get the x of t plus x of t minus x of minus t, that is with the value of amplitude 2, and again the duration is same. Okay, now this is your x of t plus x of minus t. Now what will happen if you divide by 2? Again you will be getting the signal like this. Okay, minus 1 to 1, 1, and again this is the even part of this signal. So in this case, this is xc of t. Again in this case, if you see, xc of t is same as x of t. Okay, xc of t is same as x of t, because the given signal itself is even signal. Okay, given signal itself is even signal. We know one thing, when the given signal is even signal, what we can write? Instead of x of minus t, we can write x of t itself. Okay, so x of t plus x of t divided by 2, that will provide x of t only. So suppose if you try to extract odd part of this signal, okay, they given the even signal. If you try to extract odd part of the signal, you will not get anything. You will get answer as 0, because even signal consists of only even part. Okay, so just we'll go by formula. Okay, so if you want odd part of the signal, so that is x of t, okay, x of t, and minus x of minus t divided by 2. Okay, already we are having x of t. This is our x of t going from minus 1 to 1, minus 1 to plus 1 with the value of 1. This is our x of t. Then what about the x of minus t? Okay, the x of minus t again is same as x of t. Then what about the minus x of minus t? If you calculate minus x of minus t, it will come like this. Okay, this is our minus x of minus t. Okay, that is going from minus 1 to plus 1. You are having x of t, you are having minus x of minus t. Then if you try to add both, what you will get? You will get 0 only. What you will get? You will get 0. Again, from the formula itself, you can tell x of t is there. What about x of minus t? Okay, x of minus t you can represent as x of t, because the given signal is even signal. So again the answer is again 0 only. So now now you got idea that if you are given with the even signal, if you try to extract the even signal, you will get that signal only. If you try to extract odd signal, odd component from the even signal, then that will be 0. Okay, so the same thing is applicable for other signal also. So what is the observation here? Even signal consist only even part, consist only even part, even signal consists only even part, where odd part is 0, where odd part is 0. Okay, so similarly the odd signal consists only odd part, odd signal consists only odd part where even part is 0, where even part is 0. But whereas the general signal consists of both even part as well as the odd part. Okay, general signal. Okay, general signal in the sense what I mean, general signal means what I mean, that is neither even nor odd signal. So I mean, what do you mean by the general signal? It is neither even or not odd signal. Neither even nor odd signal means, so what you will be getting, okay, you will be getting both even component as well as the odd component, both even component plus odd component. That is the observation, odd component. Okay, so now, so far we have been discussing the even and odd part of the signal with respect to the continuous time signal. Now next, we'll see one or two problem, okay, related with the discrete time signal. Okay, related with discrete time signal. Okay, so the next question is, find even and odd part of the given signal. Find even and odd part of the signal, the signal x of n is equal to u of n. Okay, if you see the nature of u of n, okay, it is a unit step function in the discrete domain. That means it is a one-sided function. So definitely it could not be even or it could not be odd. Okay, it is like this signal is neither even nor odd signal, because what is the nature of the signal? If you draw the nature of the signal u of n, okay, the u of n will be having samples only for positive time index. Okay, it will be having samples like this up to infinite, okay, 0 1 2 3 like that, with the values of 1 1 1. So it is only a positive sided signal, one sided signal, it is going towards right side. So definitely this is neither even nor odd signal. So this signal is neither even nor odd signal. Okay, so if the signal is neither even nor odd signal, definitely we can find out even part as well as the odd part, even part as well as the odd part. So what about the even part of the signal? Okay, so even part of the signal, that is x e of n is equal to x of n plus x of minus n divided by 2, where x of n is equal to u of n, okay, and then u of minus n divided by 2. Okay, so now once if you know u of n and u of minus n, then again you have to add both, then divide by 2. Okay, what is the nature of u of n? Okay, just now we have drawn, this is the nature of u of n. It will start at 0, okay, then 1 2 3 like this it is going, okay, up to infinite. What about the nature of u of minus n? U of minus n is the signal that will be going towards left side. Okay, but where it will start? Okay, where it will start, if you have confusion, you write minus n is equal to 0, that means n is equal to 0. So where the signal will start? The signal will start at 0, but it will be going towards left. Okay, so the u of minus n, it will start at 0, but it will be going towards left, okay, with the negative time index. Okay, 0 minus 1 minus 2 like that it goes on. So but if you add both the signal, this is u of n, this is u of minus n. Okay, now what you will be getting, once if you add these two signal, okay, you will be getting sample values of 1 in all the samples except at n is equal to 0, because at n is equal to 0 both the signals are having samples. So once if you try to add both, okay, you will be getting the signals like this. Okay, at n is equal to 0 you will be getting the sample value of 2. In all other case you will be getting sample values of only 1. Okay, 1 1 1 1. Okay, so this is the at n is equal to 1 2, this is minus 1 minus 2. Okay, so once if you try to add both u of n plus u of minus n, this will be the answer. Again you have to divide by 2. Okay, then only you will get the even component. Once if you divide by 2, again this will become like 1, this is 1 by 2, this is 1 by 2, this is 1 by 2, and then 1 by 2. again 0, 1, 2, minus 1, minus 2, again it is going up to infinite, plus infinite to minus infinite. So okay, now what is the nature of the signal? If you concentrate on this signal, okay, this is finally the even part of the signal. This signal is definitely a even signal, because even if you flip this signal with respect to y-axis, okay, the signal will look like same. Okay, the signal will remain same, the amplitude of the signal will not change. Okay, even if you flip with respect to y-axis, that means even if you introduce negative time index here, that will not change. Okay, so that's why this signal is the even part of the signal. So next, what about the odd part of the signal? Odd part of the given signal. Odd part means, what is the formula? Odd part of the signal is equal to x of n minus x of minus n divided by 2. That means u of n, okay, minus u of minus n divided by 2. Okay, so that means here what I have to do first, already I am having u of n. Okay, now I have to find out what is minus u of minus n. Okay, already u of minus n is there with us. Okay, from that we have to find out minus u of minus n, or otherwise we can do one thing. This is u of n, this is u of minus n. Again you try to subtract the second diagram from the first diagram. Okay, that is also possible. Okay, see, because minus, here we are applying minus operation. So what will happen? Okay, so we will directly apply that operation, just minus. Okay, so once if you try to subtract, directly we'll get u of n minus u of minus n. Okay, so what will be the value? You see here. So what is happening? Just before n is equal to minus 1, u of n is not having any samples, any value, so 0, but it is having 1, but minus 1. So 0 minus 1 is minus 1. So before n is equal to 0, all the samples will have, okay, all the samples will have the value of minus 1. Okay, before n is equal to 0, all the samples will have the value of minus 1. Okay, minus 1, minus 2, minus 3, and it goes on, okay, up to infinite. But at exactly n is equal to 0, what is happening? At n is equal to 0, this is also having the sample value of 1, this is also having the sample value of 1, then 1 minus 1 is 0. So exactly at n is equal to 0, the value is 0. Okay, next, what is happening? After n is equal to 1, this first diagram is having samples, but in the next, in the second diagram, there is no samples. So 1 minus 0, 1 minus 0, 1 minus 0. So again, simply it is 1. So the value is 1. Okay. Okay, simply the value is 1 from 1 to 3, and again it goes on like this. Okay, up to infinite. Now this is u of n minus u of minus n. Then you just put divide by 2. Okay, then you will be getting odd part of the signal. Okay, so just by 2, 1 by 2, 1 by 2, 1 by 2, and then this one is minus 1 by 2, minus 1 by 2, minus 1 by 2, and so on. So now this is finally the odd part of the signal. Okay, so if you see this nature, definitely this is the odd signal only. Okay, this is the odd signal. So again you just finally verify whether if you add, you are having even component of the signal and also the odd component of the signal. If you add both, okay, you just verify whether you are getting u of n or not. Okay, finally you are getting u of n or not. Okay, so next problem. Find and even and odd part of the signal. Find even and odd part of the signal. Okay, so x of n is equal to 1 by 2 whole power n u of n minus 3. Okay, so in two ways we can solve this problem. Okay, mathematically directly we can get the final expression. From that we can draw the final graph, or from the beginning itself we can take the graph. Finally, again directly from the graph itself we can get the even part and odd component. Okay, so we will try to get both by both the method. First, directly we will try to solve. Okay, so what about the xc of n, x even part of the signal? Okay, already you should know what is the original shape of the signal. Anyway, that I will come to the latter. Just mathematically we will go now. Okay, so x of n, x of minus n divided by 2. Okay, so 1 by 2 x of n you write as it is, 1 by 2 whole power n u of n minus 3 plus x of minus n. So that means what? Wherever n is there, you put minus n. Wherever n is there, you put minus n. So that means 1 by 2 whole power minus n u of minus n minus 3. Okay, and like this. And then what about the odd part of the signal? Xu of n is equal to x of n minus x of minus n divided by 2, and again simply only minus instead of plus, here only minus will come. So 1 by 2 whole power n u of n minus 3 minus 1 by 2 whole power minus n u of minus n minus 3. Now, okay, so ultimately we got the mathematical expression for even component as well as the odd component. Okay, so then how to draw the diagram for this one? How to get the graphical nature, graph nature for this one? How to get the samples, okay, in the graph? Okay, so first we'll take even part. We'll try to get the samples. Okay, it may or may not be correct. We'll just analyze, and also the same problem we'll try to solve with the help of the graphical method itself. So directly we will draw the graph first for this one, then from that we'll get the graph for this one and also this one. So now what we are going to do, we'll try to draw the graph for this one. So if you want to draw the graph for this one, you should know what is the sample values. When you substitute n is equal to 0, what is the overall value? When you substitute n is equal to 1, what is the overall value? So just we'll see. So I am taking xc of n, xc of n, that value is 1 by 2, 1 by 2 whole power n. Okay, u of n minus 3, u of n minus 3, 1 by 2 whole power minus n, u of minus n minus 3. Okay, so now if you put n is equal to 0, okay, when you put n is equal to 0, what is the answer? 1 by 2, 1 by 2 whole power 0, okay, 1 by 2 whole power 0, u of minus 3 plus 1 by 2 whole power 0 u of minus 3, okay, which is equal to what? Anybody? What is the answer for this? Can anybody tell me? What is the final answer for this one? Okay, so next I will write what about n is equal to 1. So that is 1 by 2, 1 by 2 whole power 1 u of minus 2. Okay, then 1 by 2 whole power minus 1 u of minus 2. What is the answer for this? Okay, and then n is equal to 2, 1 by 2, 1 by 2 whole power 2 u of minus 1, 1 by 2 whole power minus 2. Okay, when you put, I think here we made a mistake. When you put n is equal to 1, this will become u of minus 4. Okay, so again when you put n is equal to 2, u of minus 5. Okay, again when n is equal to 3, 1 by 2, 1 by 2 whole power 3, u of n is equal to 3 means u of 0. Okay, 1 by 2 whole power minus 3, u of 3. So that means minus 6, which is equal to what? So when you put n is equal to 4, 1 by 2, 1 by 2 whole power 4. Okay, u of 4 minus 3 is 1 plus 1 by 2 whole power, what is n? N is equal to minus 4, u of minus 7. Yes, sir. What is the answer for the first case? Anybody? Any idea?
U of minus 3, sir.
U of minus 3. What do you mean by u of minus 3? U is a standard function. U is a standard function, discrete signal. U is a unit step discrete signal. What is u of minus 3? See, you know this one already. What do you mean by u of n? U of n means the nature is like this. Is it not? 1, 2, 3, like that it goes. So mathematically what you are representing, u of n is equal to 1 when n is greater than or equal to 0. When n is less than 0, the u of n value is 0. So what do you mean by u of minus 3 here? where what is the value of n? You are telling u of minus 3, instead of n you are putting some value. What is that n value here? Is it positive or negative? Anybody?
Negative.
Negative. So that means what? What is the answer?
Zeros.
0. So 0. So don't tell u of minus 3. U of minus 3 value is 0. So that means this is 0. This is also 0. Okay, this is also 0. Okay. Now, what about n is equal to 3? So that time u of 0 is not 0, 1. So you will be getting 1 by 2 power 3, that is 1 by 8. Already 1 by 2 is there. Then you will be getting 1 by 16. Okay, when you substitute n is equal to 4, you will be getting 1 by 32. Again, we have to do one more thing, because we are putting for n only positive time index. Again, we have to put n negative time index also. When you put n as a negative, again what will happen? Because when you put n is equal to negative, this part will become negative, but this part will become positive. Okay, that also we have to analyze. So next what I'm going to do, I will put n as a negative value. So okay, now let's see what happens. Okay, so I'll take the same equation. Okay, I'll try to put n is equal to minus 1. Or can you tell me directly, when you put n is equal to minus 1, what will happen? Anybody? See, very simply, this will become positive, this will survive, this will go away. When you put, okay, or otherwise I'll put it in the next page. When you put n is equal to negative, okay, what will happen? The same equation I am taking, okay, xc of n, that is 1 by 2 power n u of n minus 3 plus 1 by 2 whole power minus n u of minus n minus 3. Okay, when you put n is equal to negative, so that means no need to put minus 0. Okay, 0 plus 0 or minus 0 both are same. So n is equal to minus 1. When I put n is equal to minus 1, 1 by 2 power minus 1 u of minus 4, 1 by 2 power 1 u of minus 1 means plus 1, so u of minus 2. Okay, u of minus 2. Okay, now what happens when you put n is equal to minus 2? Okay, minus 2, I think, where is this 1 by 2? This 1 by 2 is common 1 by 2, I think. Yes. Okay, again we made a mistake. This 1 by 2 is a common 1 by 2. Okay, that we have to be careful. Okay, but anyway this component is 0, but this 1 by 2 is common. Okay, again the answer will not change, because this is not producing anything. That's why our answer is correct. Okay, so now what happens when you put n is equal to minus 2? Okay, 1 by 2 whole power minus 2 u of minus 5. Okay, then 1 by 2 whole power 2. Okay, u of minus 2 means plus 2, that means minus 1. Okay, then what about n is equal to minus 3? 1 by 2 whole power minus 3 u of minus 6. Okay, then 1 by 2 whole power 3 u of 0, and you put n is equal to minus 4, 1 by 2 whole power minus 4 u of minus 7 plus 1 by 2 whole power plus 4 u of 1. Okay, now what is the value? This is 0, this is 0, but this is not 0. U of 0 is 1, so 1 by 2 1 by 8, that is 1 by 16. Okay, now this is 1 by 32. If you see there, here it's like something symmetric value only you will be getting. Okay, 0 0 1 by 16 1 by 32. Again here also 0 0 1 by 16 1 by 32. 0 0 1 by 16 1 by 32. Okay, so that means what? So I will plot it. I will take this value and plot as a simple graph. Okay, so what is the answer we are getting when n is equal to 0? Okay, when n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, and then minus 1, minus 2, minus 3, minus 4. If you see here 0 0 0 1 by, when n is equal to 3, what we are getting? 1 by 16, this is 1 by 32. Okay, 0, 0, 1 by 16, 1 by 32. Okay, so you just plot it as a graph finally. Okay, at 0 the sample value is 0, at n is equal to 1 sample value is 0, 0, but here you are getting sample of 1 by 16, here you are getting sample of 1 by 32. So 1 by 16, this is 1 by 32. Again this is 0, this is 0, and then 1, 2, 3, 4. Similarly you write it here, minus 1, minus 2, minus 3, minus 4. So again at minus 1, 0, minus 2, 0, at minus 3 you are getting 1 by 16, at minus 4 you are getting 1 by 32. Okay, this is 1 by 16, this is 1 by 32. Just I am putting here some reference, but this is not the sample value, just for reference I am putting on line, dotted line. Okay, now this is x e of n. Okay, is it a even signal or odd signal, sir? Finally, what about the nature of the signal, even or odd?
Even
Even
signal.
signal. Okay, so because we have found out the even signal, even component. Okay, for the given discrete time signal, we found out the even part of the signal with the mathematical equation. That mathematical equation we have expanded. Okay, we have expanded to find out the sample value. Then finally we have plotted as a graph. Okay, so finally this is the even signal. So similarly, if you expand, okay, if you expand this one, again you will get the answer like this. Okay, so similarly I am going to write, similarly, okay, you will get the odd part of the signal also. Okay, so odd part of the signal that I can write here. Again very simple, just you will get one extra minus there. Okay, in the formula what is there, only everything is same except one minus here. Okay, one minus here, that means in all the equation you will be getting minus here. So whenever this component is there, that is plus, whenever this component is there, that is minus. So that means what, when you put n is equal to negative, that time second component will be surviving, that time you will get minus minus here. So that means directly I can put here, say this is 0, 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. Okay, and then minus 5. Okay, 0 means 0, at n is equal to 1, 0, n is equal to 2, 0, 3, 3 we will be getting value, that value is 1 by 16. At 4 we will be getting the value 1 by 32. Then what we will be getting, most probably 1 by 64, like that it goes. Similarly here what is happening, at n is equal to minus 3 we will be getting minus 1 by 16. At n is equal to 4 we will be getting minus 1 by 32. At n is equal to 5 we will be getting minus 1 by 64. Okay, so finally this is a odd component of the given signal. This is the odd component of the given signal. Okay, so now finally how to draw, so finally we have we got some mathematical equation. From that mathematical equation we have drawn the graph. So now how to go by the graphical method. Okay, so or graphical method. Okay, that means graphical method means from the beginning itself we have to draw the graph. So what is the given x of n? X of n is equal to 1 by 2 power n u of n minus 3. Okay, this is the given question. Okay, again what is the nature of this one? Okay, so simply what do you mean by this? X of n is valid only when n is from 3. Okay, from n is equal to 3 onwards only this function is valid. Okay, before n is equal to 3 this is not valid, that means the value is 0. Okay, the value is 0. So just we'll calculate the samples for this one. So what do you mean by what is x of 0? X of 0 is 0. What is x of 1? 0. What is x of 2? 0. What is x of 3? Okay, x of 3, that time you will get value, because 3 minus 3 is u of 0. U of 0 value is 1. But what is n value? N value is 3. So 1 by 2 power whole power 3 is 1 by 8. Okay, what about x of 4? X of 4 will be definitely 1 by 16. x of 5 will be 1 by 32. Okay, so this is the original function. Okay, this is the original function. Okay, this function will have value from 3 towards infinite, all other values are 0. Okay, so we'll plot this. Okay, now this is the given x of n when n is equal to 0, 1, 2, 3, 4, 5, like that it goes again, 6, 7. So exactly at n is equal to 3 we are getting value of 1 by 8. At n is equal to 4 this is 1 by 16, and again 1 by 32, like that it goes up to infinite. And again this is the reference axis. Okay, so this is the given x of n. So what is our first step to calculate the even part? We will find out x of minus n. Okay, now we are going to find out the even part. So before that we will find out x of minus n. Okay, if you find out x of minus n, again we will be flipping the signal with respect to the reference axis. This is the reference axis. Okay, then you flip the signal. Okay, 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So at n is equal to 3, sorry, minus 3, you will be getting 1 by 8. N is equal to minus 4, 1 by 16. N is equal to minus 5, 1 by 32. Now what we have to do? We have to add these two signal and then divide by 2. Okay, so add these two signal and divide by 2. Now what we'll be getting? In place of 1 by 32 we'll get 1 by 64. In place of 1 by 16 we'll get 32. In place of 1 by 8 we'll get 1 by 16. So here also it will go like that. So directly I can write x, okay, just by adding these two and then divide by 2. Okay, so you add these two and then divide by 2. Okay, so that means x even part of n is equal to x of n plus x of minus n, okay, divided by 2. Then what you will be getting finally, uh, okay, so again this is 0. Okay, you will not have any sample. 1, 2, 3, 4, 5, okay, 6. Okay, what will happen? At n is equal to 3, instead of 1 by 8 you will be getting 1 by 16. So n is equal to 3, you will be getting 1 by 16. Okay, that means here 1 by 32. Okay, here 1 by 64. Okay, similarly here minus 1, minus 2, minus 3, minus 4, minus 6. At n is equal to minus 3, what we will be getting? 1 by 16. N is equal to 4, minus 4, 1 by 32. That means with minus, okay, minus 1 by 16, minus 1 by 32. And then at n is equal to 5, you will be getting minus 1 by 64. Okay, so now this is the even part of the signal. Okay, graphically we have seen what is the answer. Even part of the signal. Okay, next what you have to do? Odd part of the signal. Odd part of the signal, from the diagram 1 you have to subtract the diagram 2. That means the diagram 2 has to be subtracted from the diagram 1. Okay, so what about the odd part of the signal? X odd part, x o of t is equal to x of n minus x of minus n divided by 2. And also you have to put by 2. Okay, you have to put what? I think we made a mistake here. Yes, yes, even part means this will come up. Okay, sorry, even part means this will come up only, because here plus. Okay, already this is also upward, this is also upward, so both will be upward only. Okay, so again at n is equal to 3 you will be getting 1 by 16. N is equal to 4, 1 by 32. N is equal to 5, 1 by 64. Okay, so in the next case odd part. Okay, in the odd part this component, okay, this component will become like negative, because 0 minus samples, 0 minus positive is negative. Okay, so again this will become negative, but positive minus 0 is positive, so these samples will become like positive. Okay, so the odd component finally 0, 1, 2, 3, 4, 5, 6, 7. So at n is equal to 3 you will be getting 1 by 16. This is 1 by 32 and then 1 by 64. Similarly here minus 1, minus 2, minus 3, minus 4, minus 5. At n is equal to minus 1 you will be getting minus 1 by 16. N is equal to minus 2, minus 1 by 32. N is equal to, sorry, again here also we are making mistake because we'll not have any samples up to -1 and -2. Exactly the sample is starting at -3. Okay, because at -3 only we are having sample, so at -3 you will get -1 by 16, then -1 by 32, then -1 by 64. Okay, so this is the answer for this one. So from this example, okay, we are realizing that okay, we can get the answer either directly with the help of graphical approach, or otherwise we can also get with the help of the equations. Okay, mathematical equations also we can get the answer. Okay, so again, whenever you approach any problem, you try to solve by both the method. Okay, you try to solve by both the method. That's why in the examination, whenever they ask any critical question, then you'll be able to answer easily. And also you can cross verify your answer. If you know both the method, you can easily cross verify your answer, otherwise it is difficult. Okay, so next uh, okay, so our next topic is causal and non-causal